In this problem, we either want to use our multiplication rule for exponentials, our zero rule for exponentials, our power rule for exponentials, or our quotient rule for exponentials, or a combination of all of those. And so in letter A, we have 5 to the 12th power times 5 to the 8th power. When we have two bases that are the same, we can combine those exponents by adding them together. And so 12 plus 8 is 20. And so 5 to the 20th power is the simplified version of that problem. Letter B, however, is a quotient. It's a division problem. Those bases, those sevens, are the same. And so with a quotient, we want to subtract those exponents. With multiplication, we add the exponents. With division, we subtract the exponents. And so we have 7, and then 14th power minus 5 power, 5th power is the 9th power. So 7 to the 14 divided by 7 to the 5th is 7 to the 9th. In letter C, it's very similar to letter A, except now we have 3 3s, right? So we have 3 to the 2nd, 3 to the 5th, and 3 to the 8th. And so all of those bases are the same, so we keep that base, and we can add those exponents. 2 plus 5 is 7. 7 plus 8 is 15, and so our simplified product is 3 to the power of 15. In letter D, we have different bases. We have 8 to the 7th divided by 4 to the 7th. But notice the exponents are exactly the same. And so we can put our two bases in parentheses and pull that exponent out for the power rule. Now what we can do is to simplify what we have in that set of parentheses. We have 8 divided by 4, that's 2. And we now have 2 to the 7th power is the simplified version of 8 to the 7th over 4 to the 7th. In letter E, we have 2 to the 5th minus 5. That minus 5 is also in the power, and so we can see we can really just combine 5 minus 5 to give us 2 to the 0 power. But what that tells us is the 0 power of used as an exponent, we can actually calculate this. And so I definitely, if you see a 0 exponent, I do want you to calculate this. 2 to the 0 power equals 1. Now the only time that it doesn't equal 1 is when we have a 0 to the 0 power. That is undefined. Or we can also say it does not exist, DNE. Right? Everything else, whether it is a negative to the power of 0 or a positive to the power of 0, a fraction to the 0, a decimal to the 0, all of them equal 1. In letter F, we want to apply a few rules. And so we're going to first just look at the numerator and simplify that. So we have 3 to the 5th to the power of 2, so we have 2 powers there. We want to take those powers and multiply those together. 3 to the 5th to the 2 gives us 3 to the 10th. Once we do that, the parentheses drop away. And so now we have 3 to the 10th over 3 to the 4th, and we can use the quotient rule. The quotient rule says that as long as we have the same base, we can subtract those exponents. 3 to the 10th over 3 to the 4th is 3 to the 10th minus 4, and that is going to be 3 to the 6th power.